Hello and thank you for taking the time out to tune into this video. In this video, I'll show you how you can leverage Windows Azure to performance test your application using Visual Studio. It goes without saying that performance testing your application not only gives you the confidence that the application will work under heavy loads, heavy stress, but it also gives you the ability to test how scalable the architecture of your application is. It is important to know how much is too much for your application. Working with various clients in the industry, I've realized that the biggest barrier in load testing and performance testing adoption is not the tooling offered by Visual Studio, but it is the high infrastructure and administration cost that comes with this phase of testing. I mean, this is a common scenario with various enterprises where in the performance testing phase you go off to the infrastructure team asking for more hardware and they say come back after 3 weeks, or they would want to take down the server during performance testing because they have to patch the server, and similar other scenarios you might have come across not gelling too well with the infrastructure team. In this video I intend to show you how you can use the goodness of Windows Azure to effectively abstract the administration cost of infrastructure management and lower the total cost of load and performance testing. By the end of this video, you would have learned how you can automate the test rig creation for Visual Studio 2012, and I will demonstrate the same for Visual Studio 2010. But before we begin, a quick round of introduction. My name is Tarun Arora. I work with Avanade, and I specialize in application lifecycle management solutions based on Visual Studio ALM. Alright, so let's get started. So basically the marriage of Visual Studio Ultimate with Windows Azure is a great thumbs up. After all, Windows Azure just takes 5 minutes to set up an active subscription for Windows Azure. It's just flexible, the pricing, the options, it's easy to track your usage, you have great dashboards, great tooling around it. It's really easy to set up environment. You can deploy right from Visual Studio. With little effort you can automate the deployment and configuration. It's very easy to scale up, scale down, and on demand, absolutely on demand. And Microsoft promises 99.9% service uptime. Service uptime. You don't have to manage the environments. Patching of the environment is done without any downtime, and everything, absolutely everything, is managed by Microsoft. And if you have Visual Studio using MSDN, then you can do what I'm showing today absolutely at no cost. The first scenario that I intend to discuss today is running your test rig in the cloud. So the test rig would comprise of a test controller, a test agent, and a load test database running on the Windows Azure worker role and communicating amongst themselves. The dev workstation would be a normal dev workstation on-premise running Visual Studio Ultimate. And then the communication between the on-premise dev workstation and the test rig in the cloud would be enabled using Windows Azure endpoint. So what are the exact ingredients to get scenario 1 working? We definitely need a Windows Live ID to register our Windows Azure subscription. An active Windows Azure subscription is, yes, required. We would make use of the Windows Azure blob storage. We definitely need a worker role with Windows Azure endpoint enabled and a deployment mechanism such that the installation, the configuration of the test controller, SQL Server, and test agent is automated. If it's not automated, it's a manual process. You don't save time. There's no goodness. We need the load test virtual user pack. Anytime you mean to simulate a load of more than 250 users, you would use the test virtual user pack, set it up on the controller. With each pack key, you're enabled to use a load of 1,000 users. So if you wanted to simulate a load of 10,000 users, then you would have to key this in 10 times. but when we build the automation solution, we'll plug this in as well. And definitely an on-premise developer workstation with Visual Studio Ultimate to try the scenario out. It's important to understand the logical setup and deployment. First step is to upload the test controller and the test agent software, as well as the SQL Server software. Zip them up and upload to the Windows Azure blob storage. Mark that blob as public so that you can access it from without being in the same network as the blob is hosted in. Why would we want to do that? Well, we don't really need to store data in the blob. We could download the test agent, the controller, and the SQL Server software while we're doing the actual deployment. But the main drive behind storing the data in the blob is that we don't waste time during the deployment downloading all these softwares every time, right? We just store it pre-hand, and during the deployment, it's just casually picked up from the blob, which is very quick, and then the deployment can carry it forward from there. So how would this work? We would open up Visual Studio. There's an automation solution that's been built. We will simply publish that solution. Now that solution has all the logic in it to actually automate the entire test recreation process. The first step is we would just click publish. Now in the background, this would start the process of deployment on the cloud. First, it would deploy the test controller. Now how it would do that is it will go off to the Windows Azure blob storage, pick up the test controller and the SQL Server software, download it on the test controller. Those softwares, as I mentioned earlier, are packaged in a zip file. In the process, when the software is downloaded, the first step is it will be unzipped. Post that, the test controller's software would be installed, but the installation would be done in an unattended mode, which means all the prerequisites, all the keys and everything it needs is pre-set up, so it can just do the entire installation in an unattended mode. Post that, the test agent installation would begin, where the test agent goes off and gets the test agent software, downloads it, unzips it, and then does the installation again in the unattended mode. Now on both these machines, the Windows Azure endpoint needs to be enabled, which can again be done via code, which again is embedded in the solution that is being published. Now once the endpoints are enabled, the test controller and the test agent can start communicating between each other, and this is when the actual configuration step kicks in. Now the configuration for test agent, test controller is again automated. The test agent would go off and register itself with the test controller, and the test controller will configure itself to run with the load test database. So these steps are pretty much automated. Now once the environment is set up, how does the test execution happen? So the first step is we have, let's say with the previous step, we managed to get the test rig running in the cloud, and we have our dev workstation which is running with Visual Studio Ultimate. So on the dev workstation, I would simply create a load test, and I would in the local test setting files specify that, or in the test setting file specify that I would like to use the test rig which has been set up in the cloud. I will delve deeper into this when I do the actual demo, but for the purposes of logical implementation, once you click the test run, it triggers the communication channel with the test rig which is running in the cloud using the Windows Azure endpoint. This basically sends a message to the test controller with details of tests that need to be run. The test controller looks at the agents that are available, finds the agent, does the orchestration, passes on the message to the test agent to start executing the test. The test agent does the test execution and feeds the data back, as in the test results, to the load test database, and which is further fed back to the on-premise dev workstation. And once the test finishes, we get the summary page with the results, and we can go back and drill down into finer details. So this is as in, once the test rig is set up, how this is how easily it can be utilized, and you could just simply schedule tests and have them store the data up in the cloud, and then you can reflect on it from your dev workstation machine. Alright, then let's get started with the demo. The first step really is to upload the required software. In our case, the required software will be the Test Controller 2012, the Test Agent 2012, and SQL Server Express 2012. And these will have to be uploaded to the Azure Blob Storage. Now, I've already downloaded these softwares, but in the presentation on the last slide, I have the links in case you need to download them yourself. So what exactly do I need to upload these softwares to the Azure Blob Storage? I need a Blob Storage Manager. Now, if you go off to a search engine and type Azure Blob Management Tools, then you will come back. The search will come back with various free as well as community and some paid tools as well. Now, I have personally used the Cloud Storage Studio, which I'd highly recommend. They're very easy to use. They're very well supported as well. You can download a free copy from cerebrata.com products Cloud Storage Studio. So I'll just open up the copy I have here. Now you'd notice that I get basically two headers here. One is development and one is subscriptions. Now I've already created a subscription for Azure. So when you open it for the first time, you have to come in and say new subscription connection, or just simply import publication setting files, which would hook up with your Windows Azure subscription by taking in your credentials and download and set up the subscription itself. Now once you add the subscription, scroll down to the storage accounts section. You would probably yourself have to create a new storage account. Now, I've already created one by the name of Tarun's Cloud Service. Scroll down further and you'd see there's a container for Blob, right? Now, Blob container, you probably have to create a new Blob container. Let's create one and call it demo. Now, the Blob container ACL would have to be public. As I already mentioned before, the container needs to be set up as public so that when the machine is deployment is triggered, it can go off and contact the public Blob service and download the required software from it. Let's click save. The Blob container has been successfully created, and it asks me whether I would like to upload some softwares to the Blob. I'll click yes. Now you can see on the left there is demo, and then there is software. Software is the one which I've already created with the required software. But for the purposes of demo, I can come to C drive. This is where I've downloaded the software. I can go off to demo. These are all the three zip files. I can simply drag drop them here and click on upload. Now this would internally start the upload process, and for the first time it would take around half an hour to upload all these three. But that's just the one-time effort. Once you've done it, you can use it as in when you need, without having the trouble of uploading them time and again. So once the upload is completed, it would look something like this. So it would look something like this. Now I can click here and say view blob properties, and it gives me this URL here. Now this is the URL I can use to directly access these the file here directly from Azure Blob Storage. So copy this, and copy the link for the others as well. This is something we would need when we start setting up and configuring the worker role deployment process. Alright, so I've copied basically uploaded and copied the links for SQL Express 2012, Test Agent 2012, and Test Controller 2012. We're done with the Blob Storage Manager here. Now, another good thing I'd like to show you is if I was to go off to now the Windows Azure website and log in to access my subscription, go off to the portal. In the portal, the home page would show me all the services that I'm currently subscribed and using. If I go in the Tarun Cloud service, I can see the blob endpoints that have been set up for me. And once you trigger the upload there, you can configure the dashboard and start monitoring the usage of your blob. You can track all the requests, you can track the percentage of success, failures, the reads, the writes. There's a very nice configuration screen here. Be cognizant of the fact that the more diagnostic logging that you enable, that might have an impact on the on your billing as well, because that's it's going to do more tracking against your reads, writes, and store the data internally as well. So just a quick glance on the monitor screen while the blobs are being uploaded. Yeah, so we can see that it's tracking the requests and the responses and the reads, writes, and it says there have been total 58 requests that have been done to the blob storage, and so you can pretty much track this in real time and understand how the usage pattern, etc. Anyways, let's get on with the important step now. I mean, we always talked about automating the entire deployment process. So let's get on with it and open Visual Studio. Okay. I have uploaded everything regarding the automation solution on my TFS preview service. I'll connect to the project and show you the solution. So this solution comprises of a couple of key projects, and one of them being the Azure project, which comprises of deployment for an agent and a controller, both being worker processes, worker roles. If we look at the controller project I have here, I'm basically deploying the controller test controller software programmatically, wherein I basically fetch the software from the blob, download it, unpack it, and specify that this is the key exe file which needs to be run. And once the installation is complete here, then the same action is performed for SQL, wherein the SQL installation is carried out. It's downloaded from the blob, and unattended installation is done. And once this is done, the test agent installation is triggered. Same, downloaded from the blob storage, run this file in an unattended mode, so the installation takes place. Now, if you look in the test controller installer, I've got a step which is to say, now you've installed the software, do the configuration, where it goes off and calls the test controller config.exe and configures the test controller with the load test database. And also a similar action is performed in the test agent installer, where it goes off and configures the test agent by calling the test agent config.exe to go off and register with the controller. Now, some of the key information that we would need is captured in the agent and controller config files. I'll quickly take you through them. So come in here, right click, and choose the option Publish. In the wizard here, we would have to specify the name for the hosted service. Let's call it Load Test Demo, and choose a region where we would like to host it. Let's give the hosting region as North Europe. Press OK. Now we can deploy this in the production environment or the staging environment. We can point it to use the release configuration or the debug configuration. Now it's a good idea to set up the remote desktop, enable the remote desktop, because if anything fails during the deployment, you always have an option to log on to the server directly and investigate what went wrong, or try out a couple of manual steps if need be, and then try and get those steps back and put them in your Azure deployment solution. Let's look at the settings. This basically needs a certificate. So specify the local username that this is the user that would get created on your instance that is being created. So when the test controller gets deployed, a local user by the name of admin would get generated along with the password you specify here. And you again have an option of configuring the certificate directly from here. So you can choose the option create, give your certificate a friendly name, create the certificate, export it from here. And once the certificate is exported from here, it needs to be imported to your in the Windows Azure portal. Uh, it kind of acts as an authentication mechanism. Now, if you go in the advanced settings, it would be a good idea to enable the IntelliTrace. So in case anything goes wrong, you can always download the IntelliTrace logs and go through them to understand the reason for failure. We're using the Tarun's Cloud Service storage account. This is the blob container. And this is enough for us to get started. Let's press next. And let's click publish. When we click publish, you can see that it's building the solution. It's creating a package file in the background, which does take a couple of minutes. So if I expand this here, I can see step by step an update of what's happening during the deployment process. I'm just going to pause the video here and let it flow, and then once we've made enough progress, I will explain the details further. Great, so as you can see, the deployment's just completed. Let's get on and try out the agents and the controller that has been deployed. There's a one-time step that also needs to be performed here, which is we have the endpoints activated on these machines on the dev workstation on premise, and the controller that has been spun up, as well as the agents that have been spun up. But we have to create a communication group. This gives us an option to exclude certain agents, or exclude certain controllers, or exclude certain dev workstations to communicate with the controller and agent. So I've created a load test group. I'm just going to edit them. The group, and add the controller group and the agent group to this. This is just a one time. Every time beyond this you create multiple agents under the agent group, they will just automatically get added. So the group has been updated successfully. Great. Close. Now on the dev workstation I'm currently recording this session from, it only has Visual Studio 2010. So what I did was I created another machine which has Visual Studio 2012 installed on it. All I did was activated the Azure endpoint on it and gave it the same activation code. And by simply adding it to this group, I can continue to use the agents and controllers from this machine directly now. So I've logged into the workstation which has Visual Studio 2012 installed. But just a quick glance at the Windows Azure monitor for the compute instance for my worker role, and I can see that during the installation process, while the test agent controller were registering themselves. Anyways, that's good to know, and we can start the session and test out the agents and the controller that's been configured. I'm going to right click Visual Studio and run as. Now it's very important to know that you run Visual Studio as the same admin user account that you created while you configured test agent and controller. That this is a shadow account. If you run with the same account, then you will be able to connect to the controller or the agent. If not, then it wouldn't work. So I've created a local user on my dev workspace, which is admin, and it has the same password. Click OK, and this I will create a new okay I will create a new new test project. Let's call this web performance and load test project as load test demo 2012. Click OK. Right, now I'm just gonna get rid of this first web test, delete this, right click the project and choose the option of add web performance test. This should bring up IE, which is the load test recorder. Okay, now before I begin the recording for the test, I will show you something. I'm gonna go off to my blog, and if I click in the administration console, I can see the um, you know, the clicks for one of my blog posts. Now this one that I've posted recently just has 19 views. So I'm gonna run my test. I'm gonna record a web performance test to hit this URL, and then I'm gonna do a load test, which again simulates a load of, let's say, 1,000 users on the same URL. And when we finish, idly the user count, if I run the test for 1,000, should go up to 1019 web views. Okay, so I'm just gonna pick this URL up and put it in the IE recorder for my web performance test. Hit enter. Okay, and this is basically recording the web request and the response it receives from the server, along with anything else it needs to load in order to render this page. I'm just going to perform one simple test, no additional actions. I will press stop. This should in the background now start calculating all the request response and generate the the sequence and the web performance test code that it needs to run this test again. Voila, the test passes. Now I'm just going to click on this test and press run test. I can see that it's just making requests, getting the response, and basically the test should pass at the end of it. Okay, so the test passes. Now if I go back to the admin page and click refresh, remember we just had 19 views earlier, we have 24 now, and the test has been recorded. Let's use this as the base to create a load test. So right click here on the project, click on add, click on load test, and let's click next. Now let's call this load test demo for 2012, and let's click next. Let's use a starting load of 25 users, and let's or the other way around, let's use a step load. So we'll start with a count of 10 users, and after every 5 seconds step up the load by 10 users and take the load up to a maximum of 1,000 users. Press next. Now let's just keep the default settings here and add the web performance test that we've just recorded here. Click OK. Next. Now let's try and simulate the user traffic for different type of connections. Let's say a dial-up as well, and maybe how about a cable connection. Press next. Now we will try and simulate our users coming in from different browsers like Chrome, IE, Firefox, maybe a mobile device as well. Press next. Now add computer. I can try and get the logs from the controller and the agent. So if I go back to the Windows Azure portal, I can see that the controller name is listed here. I can copy paste that and enter that there. So you can see here I have added the controllers, I've added the agent, and I've added the other agent as well, just to collect the logs from them. Click next. Load test duration. Let's run the test for 10 minutes. Um, let's set up the validation level based on our web test recording to low, and click finish. This generates the load test based on the inputs we entered. It generates the scenario for us for our load test. Nothing much to do here. Let's just fire the test off by. Hang on, there's an important step here. Uh, this would pick up the test controller and the test agent from the local test setting files. Alternatively, we have the option of managing the test controllers from here. So the test controller is RD0155D3691DF. This is it. Look, it shows you all the agents. Both the agents are associated with it. What did I have to do? Nothing. Through Azure, I just deployed my solution that set up the controller and the agents, and from Visual Studio, I can see them here. Brilliant, right? I can bring them offline, restart them, perform all the actions right from within Visual Studio. And great. So let's look at our local test setting file and go to the roles, change the local execution to remote execution, and enter the controller name here. Now once I enter this name here, we see the icon here which says it's trying to connect to the controller, and the icon now changes to this plug sign here, which shows that it's connected to the controller now. And we can add the roles for our agents, etc., etc. But I'm just going to skip all that. Click apply, close this, and run the tests. We can see it's performing some action here. Test run pending, so just trying to create a session with the controller, and then the controller would further orchestrate that to the agent. It should hopefully bring up the window where we can see the real-time execution of our test and results as well. Okay, great. The status has changed from to in progress now. Great. So it's loaded the load test analyzer view during the test execution. It's slowly starting to bring up the metrics as well. I can start to see the page response time, and along with other metrics, details of the system that is under test. The page is not that bad. It's quite responsive. Just gonna pause this and wait for the test execution to complete. Great. So the test has just completed. I can see the test summary view, which gives me a crisp representation of start time, end time of my test, the controller, the number of agents. So we actually managed to reach the load of 1,000 users. Each test ran at an average of about 1.13 seconds. It gives me all these important pieces of information that I can make use of. And apart from that, I can see that the controller was just very underutilized. It was just about 10% of process time on the controller, and I can see the exceptions that came up pretty quick here. And apart from that, over here I can see that 95% of the requests were 95% page time per second, and we're done in about 258, and about 5% of the slowest pages here as well. I can go down to the graphs view. It shows me all those metrics plotted on the graph, so I can drill down as well. Now let's look at the test project. We did the load test demo 2012 when we ran the web test 1, and I can see the average, let's say, average test time. So the average test ran for about 6.37 seconds. I can go down to the pages. I can get the information about this specific page, and I can ask questions like how many pages were served per second. It's just getting the information out for me. So minimum 0.017 and a maximum 25 seconds. Not that bad. So overall, I can run my test. I can see the metrics in real time. I can have the metrics loaded from the database. Once the test finishes, I can see the summary screen. Great. So going back to the presentation, we've just finished the demo. Some great resources I came across while I was preparing for my session, and some useful links just captured in this resources slide here. MSTN's got some great guidance around Windows Azure, Visual Studio, around load testing, so you could use this link. The blob storage manager I used for uploading software to the blob, like the test controller, test agent, zip files. I use the Cloud Storage Studio. You can download that using this link. Links to the Visual Studio 2010 as well as 2012 agents and controllers, and the SQL Express available in the resources page. If you'd like to keep in touch, please use these channels. I'd love to hear your feedback on features we could add to this, or any other advancements you've made in your enterprise with load testing. Thank you for your time, and I've today just discussed scenario 1. Yeah, just crisply bringing up the slide here again. Stay tuned, because in the next video I'll take this to the next level and discuss scenario 2. I'll just give you a glimpse of it. So scenario 2 will be running multiple test rigs in the cloud. You could have another one here which is running test rig on-premise, and then synchronizing everything from your different test rigs down to the SQL Azure database, and then doing your aggregation for all the testing effort done in your organization in one place, and doing reporting off of that. How cool is that? Stay tuned. Thank you for taking the time out and watching this video. If you have any feedback, then please do write to me.